determine the integral from 1 to e to the power p pi sinus of ln of x. First we want to get rid of the term ln of x, which can be done by substitution of u is ln x. So du dx is a derivative of the logarithm is 1 over x, or dx is x times du. But x is now the inverse of u, so e to the power u du. So the integral we have of sinus ln x dx may be transformed using the substitution rule. So if x is going from 1 to e to the power pi, then x is going from 0 to pi. The sinus of u times eu du. Yeah, so here we have dx is eu du that we found here. So what we do now is apply integration by parts, since you might have noticed that this is actually a kind of standard integral. So we're going to differentiate the sinus of u and take a primitive on the e to the power u. So first this will give us sinus ueu between the values 0 and pi minus, now we're going to truly differentiate sinus of u, cosinus of u. So at the first part we arrive at 0 minus integral 0 pi cosinus ueu, and since this integral is rather standard, you know that if we do the same thing all over again, we arrive at the sinus ueu integral form. So here we carry out this task. So first we get the integral cosinus ueu between 0 and pi, and here we have a derivative and the primitive of eu. So which means that actually, if we look on the left hand side, we started off with the integral, and here we have the same integral with a minus sign on the right hand side. So if we remove it to the left hand side, we get 2 times the integral is 1 times minus the cosinus ueu between the 0 and pi, which is e to the power pi plus 1. So the integral is actually half of this value, e to the pi plus 1 divided by 2.